In today's video, I want to take a look at a short introduction on how to use threads under Linux in C. First things first, we need to include here a header file. So I'm gonna include pthread.h. And one more thing that you have to do extra besides just including the file itself is a link option, right? And this link option goes to the command that compiles your source code. So my command is found inside tasks.json, and I have added it here, -pthread. So if you're using VS Code, you just have to add it here. Otherwise, you just have to add it wherever as an argument to the GCC command. That's very important. Otherwise, nothing is going to work regarding threads. All right. Now that we have that, we can start creating threads. Now, the basis of creating a thread is that when you create a thread, it executes a function, whatever function you create. So we're going to start by creating a simple routine that does something very generic, and we're going to try to execute it using the thread creation. So what we'll do here is just create a function. I'm going to call it just routine, but can be anything else. And I'm going to give it any arguments. What I'm going to do is just add here a printf saying test from threads, let's say \n. Okay, now that we have the function, to start creating the threads, we first have to define a sort of place where basically the API can store some information about the thread. And that place is a variable, of course, but the type is pthread_t, and I'm going to call it t1 from thread 1. And you'll see exactly where this is going to be used. Now, to initialize the thread, we just call the pthread_create function. And this guy looks a bit more complicated than other basic functions, but trust me, it's not that scary. The first parameter is the pointer to this t1 variable that we have created here. So it's just simply you pass in a reference to it. That's very simple. Next up is the attributes. So these attributes are regarding customization of certain things that you can do with threads. But what you can do, since it's a pointer, you can just pass null, and it's going to set it up itself with default attributes. So you don't have to deal with that. Next up is the actual function that is going to execute when it creates the thread. We're going to just pass in routine, but to pass in a function as a parameter, we have to pass in, of course, a function pointer. So I'm going to get the reference to that routine. And lastly is the argument that is going to be passed to the routine. Since we don't have any arguments here, I'm just going to pass in null, and it's not going to pass anything else. Okay, one last thing we have to do, similar to how we do with processes, is we have to wait for that process, or for the thread in this case, to finish its execution. How do we do that? Because usually you don't want the process to finish its execution and then the thread to be in the middle of executing something. You know, that's gonna just terminate the process altogether. So what we have to do is call another function that says pthread_join, and this is basically the wait, but for threads. And we just pass in here the actual struct, so this t1 that holds the information for our thread that we have created here, and then we can pass in some pointer that gets the result from that thread. But since we don't return anything, we don't do anything special with the thread, we don't care about it, we're just gonna pass in null. And that's really all there is to creating a thread. Just create a struct, a variable where you can store some information about the thread, call the pthread_create, call the pthread_join, and you're basically done. Now, if you try to run this, you'll notice we're gonna see test from threads printed on the screen. So that's very nice, but how do I know that this is in parallel? Well, we can try to create more threads. So if I want to create another thread, what I have to do is declare another pthread_t type variable. So t2 here, call pthread_create again. So I'm going to change this to t2, and I'm going to call or execute the same function. So we're just still gonna call the same function, but it's gonna be from a different thread. And of course, wait until it's finished executing. So T2 as well in here. Now, if I try to execute this, I'm gonna see this printed on the screen twice, of course. But how do I know again that this is in parallel, right? We are dealing with threads, we're trying to execute things in parallel here, but it's kind of difficult to figure it out. Well, what we can do is print two messages inside the function here. I can say printf this message, and I can wait a while. I'm gonna call sleep and wait, let's say 3 seconds, and I'm gonna print, let's say, ending thread, right? And if this function would be executing twice, one after the other, you would expect that first you'd see test from threads on the console here, and then you'd see ending thread, and then again test from threads and ending thread. But if you try to execute it, you instead see test from threads twice, and then ending thread twice here. Although I did forget a \n, so let me just fix that and execute again. You'll notice that we get that twice. So that means that both threads executed that printf statement. It got to the sleep of 3 seconds, so both threads kind of paused their execution for 3 seconds, and then it printed again ending thread at the same time, more or less. Now, one important thing before going is to error check Oriole function calls, because here I'm assuming that I can create these threads, but in actuality, in a Linux environment, you can actually suppress people from creating threads, or simply just not have enough resources to create those threads. So there could be some errors occurring behind the scenes. Therefore, we're gonna check here. This pthread create, for example, returns an int, and this int is either 0 or something different that represents an error number. So what we can do here is to just add an if statement that says if whatever returned pthread create is not 0, that means that there was an error that occurred. I'm just gonna return an error code myself, so return something different than 0, and do the same for all the pthread related functions. I'm gonna return 2 here. Let's say these numbers, these return values don't hold any meaning right now, but we can give them some meaning if we want to. And now if I try to launch this, it's gonna be the same, of course, but at the very least we know that our code is a bit more safer than before. Alright, that's about it for today. If you do have any questions, do leave them down in the comments below or on our Discord server. You will see the source code up on the CodeVault website. I'm gonna leave a link to this specific lesson on the website to it. And otherwise, take care.